type Erasure in Qt5. And thank you.
Thank you. So hello and good morning. I am Stephen Kelly. I work with KDAB. I am a C++ developer for a few years now. I'm a Qt maintainer. I maintain the item views module in Qt5. I also maintain the CMake files that we ship with Qt5. I've been a KDE developer about 6 or 7 years, and I've made many contributions to Qt. I also have a personal project called Grantly. It's an implementation of a domain-specific language. It's a port of the Django template system to Qt. I'll be showing a little bit of that. Recently, I've become a Boost developer, and I've also been a CMake developer for 2 years. So when we're talking about type erasure, there's some funny definitions that you can find on the web. We want some kind of common interface to one type. We want some common interface to a wide variety of types so that we can treat those wide variety of types uniformly and without knowing exactly what type we're dealing with. And of course, in Qt, what our goals are, we want to hold distinct and unrelated types. So the types don't have to be a subclass of each other or anything else. We want to be able to convert between types. So if I have a number, I want to be able to convert it to a string. I want to be able to store instances of that thing in a container, copy them, and assign them. So I need to be able to do a lot of different things. Of course, in Qt, the central class that we use for that kind of thing is the QVariant class. You see that class in a lot of APIs around all of Qt. For example, in the item models API, the data method returns you a QVariant. So that means in your implementation, you can return many different types from there. To show a string if you're displaying some data, or to return an icon if you're showing an icon. Also, if you're doing an animation, you'll find the QVariant API in all of the animation API, because almost anything can be animated. You know, a number, a color, anything like that. Also external to Qt, Qt base at least, you'll find domain-specific languages which make good use of type erasure. For example, QML, as you know, it's based on JavaScript. JavaScript is not as strongly typed as C++, so you need some runtime type introspection to find out, can I iterate over this type? Can I assign something to it? What properties does it have? Everything like that. Similar with my Grantly library for text templating. It's a domain-specific language. So it's a language that I implemented just for a specific domain. You'll also see a lot of type erasure in language bindings, things like PySide and PyQt, and RubyQt, Smoke, all the Qt language bindings that exist. They all rely on type erasure because, you know, Python doesn't know. Python has, you know, a runtime type system rather than a compile time type system too. So an example of where you would need to handle a variety of types in a domain-specific language would be something like this. In your QML, your rectangle has a color, and you can specify it many different ways. You can give a string. You can call this RGB function on the Qt namespace and get a color back, or you can give it some kind of enum. So somewhere inside of the QML engine, there is an interpreter. There is a method, I guess, which looks at the type of the incoming of the property value and sees if it can convert that to a color somehow. And this is what a text template system looks like. So this is the syntax of Django and of Grantley, my one. You don't have to try to memorize what you're looking at here. This slide shows up a lot of times when I'm pointing out specific things. But the things to notice are this is a HTML template, which I'm generating. I've got some curly brace syntax for getting a user's name. I've also got a number of messages. I'm showing how many messages there are, and I'm looping over them. And then I'm displaying some things from the message inside of HTML list items. So this is sort of the goal that we want to achieve using the Qt built-in type Erasure facilities. You know, if you are a third party, you want to create something like this, I'm going to show you how to do that and what API to use. And just to show that it's a real thing, I have the same template here in a main HTML file, and inside of this application I'm creating a user called Steve. I'm putting that into a QShared pointer, and I'm creating 3 different message objects. I set the sender and the content on each one. I set one of them to urgent just to show another feature. And then at the bottom I'm inserting this into some context object. Other hidden code that you're not seeing on the screen is just loading that HTML template that I just showed, and using the content to render, using the context, this user, to render that template. And the result is, of course, hello Steve, and some mails. So this works with both Qt4 and Qt5, but it takes a bit of crude external scaffolding in Qt4. With Qt5, you can do this very easily. So this is all the syntax that I'm looking at for now. What I want to point out is accessing properties of objects here. So I have a user object, and in my C++ code I created a user object and I gave it the name Steve. And here I'm trying to access that by the name property. The name, of course, is just a string, and while I'm concatenating, while I'm processing that template, all I have to do is append a string. But for something like user messages length, that's obviously a number, so I'll need to be able to convert from the number to the string. And down here, I've got a condition saying if the message is urgent, then show this extra image. So I need to be able to convert from a Boolean from a QVariant in a Boolean, from a Boolean in a QVariant to some kind of Boolean so that I can do tests like that, given a QVariant. So things like equivalent colors, like I showed in the QML example, you need to be able to do conversions like that. Need to be able to access properties using some kind of syntax. I've got just dot. And given a container, I want to be able to process any sequence that I have, any mapping that I have, using this simple for syntax. So in the example that I showed, I created a few messages, and they were added to a QList of message objects, which can then be handled by this simple for syntax. So last year, this is a slide from last year, I gave a presentation about how QVariant works. I'm not going to go into too much detail now, but I'll just tell again the basics. So these condiment containers, what they contain is determined at build time. The one with the S obviously has salt. The one with P obviously has pepper. But if you look at these containers, you don't actually know what they contain, because I come from Ireland, and in Ireland we put salt into the one with one hole. But here in Germany, they seem to do the opposite. So if anybody gives you one of those, you don't know whether to put it on your dinner or not until they also tell you what's contained in it. So the QVariant it stores not just an object, it also stores a type. So it can tell you whether it's containing a string or a number or anything else. And similarly now with Qt5, it can tell you if it has a container in it. And that means if it has a sequential container in it, it can tell you that. And then you know that you're able to iterate over it. Or if it tells you that it has a mapping inside of it, you can look up some keys in the mapping. So back to today. We're interested first of all in conversion. The QVariant API, or the QVariant class, has a lot of API for doing conversion to built-in types. So you can convert from an integer to a string, from a floating point number to a string very easily, from a string to a string. You can also convert to a Boolean very easily. So it has a concept of truthiness. You know, a non-zero number is true, and things like that. A non-empty string is true as well. So this QVariant API also appears in our QObject class that has a method called property. And using that property method, we're able to access things on the QObject. So we have to set up properties like that using the QProperty macro if we want to have a static property. And then once we've done that, we can use this property method. In this case, we call name, or we give it name. That gives us back a QVariant. We can call toString on that to get a string back. And if I access the numMessages property, I call toInt on that to get an integer back. Of course, I could also just convert that to a string if what I'm doing is templating some text. But now maybe you can see at least how these highlighted parts of my text templated system work. User is a QObject subclass. It has a property called name. And my engine just has to look up that property, convert the QVariant to a string, and append it. Similar for the messages length. My engine doesn't care that length is actually a number. All it does is it asks the QVariant to convert it to a string, and then I can append it to my result to generate my HTML. So you can do a lot of conversions, a lot of more conversions in Qt5 now as well. So a lot of these conversions were not possible in Qt4, but in Qt5 now you can convert. If I put a QFile pointer into a QVariant, I can extract it as a QObject pointer. And if you write a class called user and you put a pointer to that into a QVariant, I can extract that as a QObject as well. So that means my text templating system is compatible with your QObject subclasses. You know, I don't need to process your headers in order to extract your classes as a QObject star. That static cast is built in. Not only that, but if you're using any smart pointer from Qt and putting that into a QVariant, my text template system can also handle that because that's built into Qt5 now. It sees that the template type user inherits from QObject, and it sees that that is part of a QShared pointer or part of a QPointer, QWeak pointer. and then it can extract that as QObject star. And you might think that there's ownership issues or memory lifetime issues there, but really any time that I extract a QObject star from any QVariant, I don't know anything about the ownership of it. It could be parented to something or not. So yeah, there's no extra memory issues, at least from that point of view, if using smart pointers. So that's all new in Qt 5. And you saw in the code that I showed at the beginning that I was using a QShared pointer to a user. Here, just for conciseness on the slide, I'm also using the auto C++11 keyword. And as usual, whenever we're putting a custom type into a QVariant, we use from value, and we just pass the object. And then later, inside of my code, my text templating code, all I did was call the value method, specifying the template type as QObject star. And that actually gave me this same user object, which I created up here. Once I have that, I can call any QObject API on it that exists. So in that case, I invoke property, passing some kind of name, and convert that to a string. So all of the highlighted stuff on this slide is just QObject subclasses or shared pointers to QObject things. Yeah, so just to note that in Qt 5, whenever you're dealing with something which inherits from QObject, your users now have a lot more options in how they interact with your system. Another item that I have is iteration. So my user has a bunch of messages. So I have down at the bottom a QProperty, which is of type QListOfMessage star. It's named messages, and there's some way to read from it, some way to write to it. And I have the message class definition up here as well. It also inherits from QObject. It has the content property and the sender property. And of course, as you saw, once I have a user, I want to be able to get its messages, iterate over them, and display them. I also want to be able to count the messages, so get the length. And from the point of view of my text templating system, in Qt 4, I didn't have any options at all. That's why I had to build a lot of external scaffolding in the Grantley library. But with Qt 5, you do have more options. So as usual, I get my user object. I don't care if it's a shared pointer or anything. I get it as a QObject star. I call the property method on it, specifying the message's name. So the property with that name will be read, and I get a QVariant back. Once I have that, with Qt 5, still I can't get it out as a QListOfMessage star, because my text templating library doesn't know about message. So that's not an option. I also can't take it out as a QListOfQObject star, because the fact that it's actually a QList container was never recorded. It's actually irrelevant. We'll see why later. So that's also not an option. But with Qt 5.2, I can take it out as a QVariant list. And that's because the message, because it inherits from QObject, can be converted to, or can be stored in a QVariant. And therefore, if I do have a list of message pointers, that's somewhat equivalent to a list of QVariants. And of course, once I have that list, I can iterate over it. I can do anything I like with it. Convert the objects inside of it to a QObject star, read its properties, etc. But that would mean looping twice. I mean, obviously, if I have this QVariant and which actually contains a QList of message stars, and I extract a QVariant list from it. Internally, QVariant lists over the container, loops over the container that's inside of it to create that QVariant list. And then once I have it, I'm going to loop again. So that's twice doing the loop, which obviously we don't want to do. We only want to loop once. So instead of actually using value to take a QVariant list out of that QVariant, we can take out a QSequential iterable now in Qt5.2. We still need to check first if we're able to convert it to a QVariant list. And once we know that we can, we extract from it a QSequential iterable. And then we can use that object, this iter object, in a Qt for each loop. So this is only one loop. Each item in there is a QVariant. Each item that I get out of the iterable, is a QVariant. And I can do the same conversions. So I can use toString if the thing inside of it is a number and I just want to convert it, append it to my result. Or if it contains a QObject, I can take that out, read its properties, etc. So obviously the body of this loop is not shown, but what you would be doing is checking, can I convert this to a string? No. Can I convert it to a QObject star? Yes. Okay. Do that and read the property. So that was the Qt for each loop, but you do have more options. You can use a regular C++ for loop too, once you have this QSequential iterable. It has the operator ++, it has begin and end. So any C++ loop that you've seen before, you can do the same thing. It also has operator arrow, so that I can check if I can convert it, do the conversion, get the value out. So because it has begin and end, and because it's a iterable type, we can also use C++11 iteration. So this is range-based 4. It's part of the C++11 standard. And if I try to use that with this QSequential iterable object, it just works again. So a bit of magic in there. I have a QVariant. I can process each QVariant, again, do conversions on it, append to my result, read properties, everything. So that's sequential containers. With Qt5.2, you're able to do that kind of iteration over a container inside of a QVariant. If the container is a QList, a QVector, stack, Q, QSet, QLinked list, and also if it's a std vector or a std list. As long as the template type can also be put into a QVariant. So that includes, all built-in types like integers and things like QString, QDate, but also any QObject subclass. If you have a pointer to any QObject subclass since Qt 5.0, you're able to put that into a QVariant straight away. Of course, not every container that you have is sequential. You also have associative containers. And you might have a property which returns for you some kind of mapping. And obviously, because again, I don't know about message, I can't extract it as a QHash of QString message. I also can't extract it as a QHash of QString QObject star, partly because I don't actually know that it's a QHash. It might be a QMap. It might be a std map. But I can, since 5.2, Qt 5.2, extract it as a QVariant hash. I can also extract it as a QVariant map if I wish. But again, the problem is that would be looping twice. So I can do the exact same thing as I had with the sequential containers before. I can check if I'm able to convert it. then I extract an iterable, and then I'm able to do regular iteration using that thing. So for the associative containers, there's built-in support for QHash, QMap, and STDMap. So that's all of the important ones. There's also built-in support. Technically, QPair is an associative container. If I have a QVariant, I can check if that's convertible to a QPair, and then I can extract it as a QPair. I can extract it as a QVariant pair. That's a type def that doesn't actually exist yet. I'm going to have to submit a patch to submit that type def, but that I just put that in the slide because it's a little bit cleaner than QPair, QVariant, QVariant. So any QPair where both the first type and the second type can be in a QVariant, you can use this to extract it. And that works also for standard pair. And now you can see, or possibly imagine, how something like this for loop would work. Messages, again, that's a property on a user type. Here I have a user instance. I read the messages property. I create a Q-sequential iterable. Loop over everything. Check if I'm able to convert the type to a QObject. I expect to be able to, because message inherits from QObject. Then I have message. I can read its properties. So I read sender and I read content. And then syntactically, I just end my for loop. So, you can have any kind of domain-specific language with any type that you like, but I'm just pointing out how it can be implemented and how it can work. So even more about conversion. So first of all, I talked about built-in conversions, which have always been there, so since Qt 4. Then I talked about new conversions in Qt 5.2, so that you can convert smart pointers of a QObject derived type into a QObject star. But you can also extend the Qt conversion system using a couple of macros. So standard share pointer, that's newly standardized in C++11. That's a smart pointer. It's quite similar to QShared pointer. If I use this macro, just like you would use the QDeclare metatype macro, if I use this one, now I can process a standard share pointer of QString or QObject in the exact same way as I can use a QShared pointer. Similarly, if I want to iterate over a standard deck or a standard forward list or any of the boost containers, again, I would just use another macro, QDeclare sequential container metatype, specify the container name, and now my text template system is able to iterate over that and take out QVariants from it. So a little bit of magic. And again, same with the associative stuff. Any questions on that so far? Yeah. Let me get you a microphone.
Where do I put this? In a header file, C++ file? Do I put it once? Do I put it multiple times?
You put it once in maybe your main.cpp file, or you'd put it in the same place where you put your QDeclare metatype when you're doing Qt 4 based code. In whichever file that you use QVariant from value, you put this in there. So generally, it's only needed once.
Will this avoid copying the containers when converting? Okay.
Yeah. So does it avoid copying the containers? Yes, it does. Because QVariant is it uses implicit sharing. Anytime that I copy a QVariant, nothing happens. But also anytime that I use the this iteration API, it also avoids copying the container, yeah. So yeah, I think that's pretty cool stuff, all built into Qt5 now. But there's more. There's more about conversion. So some of you might have been in the Lightning talk yesterday by John Melas. He talked about using the QVariant string conversion stuff for constructing strings. So something like templating, but on a smaller scale. And he said it's very useful to be able to convert a QVariant to a string. And he had a simple class which took a QVariant, converted it to a string, and outputted that into a result, so that you could process a QDate or a QPoint or anything like that. So also new in Qt 5.2, you're able to specify converters from any type to any other type. That was written by my colleague Christoph. But the API is just register converter. And here I pass a function pointer to the toString method from some kind of source type. So here I want to be able to convert from a roles instance to a string. So I use register converter, and that figures out that the return type is QString, and it sets up a conversion from a roles instance to a QString using that method. So John's trick from yesterday could be could benefit from that kind of conversion. But not all of your types are going to have a toString method already, so you can write your own converter function, some kind of free function, and say, it takes as an argument a roles instance, and it returns a QString, and you can register that as a converter too. And you can also use a functor as well if you wish. So lots of new ways to convert between things in Qt 5. Yeah, and just to show you a complete program, I know it's a lot of text on this slide, but it just about fits. We can imagine that these methods have some kind of sane implementation. And the toString method was a bit more sane, so that it would tell you whether the delete write is available and the create write is available, etc. Because roles does not inherit from QObject, I need to use QDeclare metatype there. And then inside of my main function, I create an instance of it. I register the toString method as a converter from a roles to a QString. I put the roles instance in a QVariant, and then I can QDebug that, and that outputs, well, exactly what the toString method creates. So that conversion API, this register converter, is actually what's used to implement all of the sequential container iteration and the associative container iteration, and also the smart pointer handling. It's all done using this this new extension in Qt 5 for registering converters between any two types. So that is my talk, basically. All type erasure in Qt is based on using the QVariant class. So that's why you see that so often in many different Qt APIs. Qt 5 brought a few, Qt 5.0 brought a few extensions and new features into QVariant. Qt 5.2 brings even more. So I showed you the generic handling of any type which inherits from QObject. So you can handle a pointer to it, a smart pointer to it, a third-party smart pointer to it. I showed generic container handling. So I didn't show that you can get the size of a container, but that's obviously also possible. I showed that in my text template when I was checking the length of the messages. I also showed how you can iterate over a container without copying it. Obviously, each item in the container, well, at least the pointer to it gets copied whenever I'm doing the iteration, because a QVariant has to be created on the fly. It's user extensible, so you can use it with any third-party types or any other type, from another library if you're using Boost or anything else. And you can also now do user-defined conversions in Qt 5.2. So converting to strings easily and converting to anything else. Thank you.
Hi, I've got two questions. The first one, what's the QtoString for QObject doing, your default implementation, I guess? Is that just returning the class name?
I'm sorry, does this relate to this class?
No. Assuming you put a QObject, an arbitrary QObject pointer into a QVariant, and then at some stage you do a toString, what's the default implementation for that?
There is none, actually. In my text template system, I never try to convert a QObject to a string, but I always read a property from it. So user is my QObject, and I read the name property, which is a string. So I never had only user in.
So that's definitely, so I always have to have a property essentially in order to
Correct.
make that work.
Yeah.
Okay, and my second question?
At least as I've implemented it, you could define your own conversion function.
And the second question is about the converter function. So I assume if you pass in some kind of function pointer to some conversion function that, assuming it returns a QString, how does it associate that to my type being the one that is the one that goes? That this function pointer is used for this type to do a toString. Is that just taking apart the signature, or? Yeah,
that's just clever stuff. Clever type introspection that's possible with Spine, in C++ templates. So it knows this type. If you can write a clever C++ template to make sure that you can extract that information. Yeah.
I guess it's quite related, but since you've named in roles the method to string, how does register converter actually know that you are talking about strings?
The return type.
So it's based only on the type. Okay.
So yeah, that same clever template that I mentioned, it can see the return type, it can see any parameters that the thing takes. So obviously we expect no parameters. It can see the class that the method is on as well, whenever I pass in a function pointer like that.
And so if we passed something different like integer or boolean, will it also work for other conversions, or
it
just
will, yeah.
this type? Okay.
Yeah.
Okay.
Okay, I'm not sure whether the previous question already answered, but QVariant already has quite a lot of logic built in to convert between multiple types, and of course we want to add our type. The question is how can we plug into this already logic? For example, I just want to return an integer value. I don't want to write all the converters for changing this integer to string and changing this integer to float and back and forth. So is it possible just to register your own new type with one of the return values and somehow reuse the already existing converter functions from the QVariant?
I'm sorry, I don't really understand the question. So the existing conversions, they're already built in. So there's nothing that you need to do in that case.
So okay, so if we have, for example, roles, and we only register to string to it, and let's say that our roles in fact have a string names for let's say numbers. So if I put this roles object into some QVariant and somebody then runs QVariant to int on it, will it work?
If they've registered a converter function which returns an int, Yeah.
Okay. So you have to write all the converters that are supposed to be used.
You need to register them, yeah, all.
I now have two questions. I had one before, but I now have two. Maybe let me start with that one. Would it work if I registered a conversion to QVariant and then profit from the built-in conversion to an int there?
Actually, I think that would work. I haven't tried it. Maybe I should add a unit test for that and make sure that it doesn't segfault. But yeah, I think, I mean,
Okay.
yeah, that should work, but do almost nothing. You know, it would be a no-op.
Well, it would. You would return a QVariant. No, you would return a string put into a QVariant and then rely on that built-in logic to get an int out of that, right? I think that was his question. I have a user type. I convert it to something that QVariant can convert to anything,
Yes.
and then do that.
I understand. No, you would. That's not built into Qt at least. You would need to take that out as a string and then do the additional conversion to int. Yeah.
Okay. And my real question was the macro for declaring a smart pointer or defining a meta type for the smart pointer. How does it work? Because I mean, does it assume that your smart pointer has a conversion to the built-in type, to the underlying type, or pointer at least?
It assumes operator arrow.
Okay.
So it uses operator arrow to take out the pointer to the templated type, and it uses spine to determine that it actually inherits from QObject. So if I had a std shared pointer of int, and I tried to take one of those out of a QVariant, it wouldn't even compile. Sooner.
So this conversion looks really interesting, but the next step is comparing to QVariant with user types. Is that also possible now, or is it something that you have on your drawing board?
It's a good question. If I compare to QVariants, just for people who are not aware of it, if I compare two QVariants which contain non-built-in types, they're actually only compared by address. So it might actually be, it doesn't invoke operator equal on the contained type, but that might be a good extension. It's not something we've done yet, but yeah, maybe for the future.
Any other question?
Hello.
Hello.
The question is, when you perform this QObject to QString conversion, are there any runtime lookups, or if we rephrase, what's algorithmic complexity in respect to number of registered conversions?
Can you repeat the question?
So my question is, are there any runtime lookup when you do QObject to string conversion? So does the speed of conversion depends on number of registered converters?
Yeah. So that question is about the implementation of QMetatype, because all non-built-in types are all declared and registered at runtime. They're stored in a sequential container, and yeah, so the more types that you register, the more time it takes to find them in order to find a converter function. But I've never had that be any limit in any benchmark. Except actually David 4 had an example with multi-threading, I think, on Monday, but that was very low-level stuff.
Okay, thank you very much, Stephen.
Thank you.
And the program will continue at 11:30, so have a break and come back to it.